question 1, which one of the following cannot be an intersection between the equation y equals to fx and x equals to f bracket y? That is the inverse. Okay, how do you find the inverse? You find the inverse by change x to y, change y to x. So that representation means that's an inverse function. Okay, so you want to find point of intersection on that. So as last lesson we talked about, if you're trying to find point of intersection, it must be intersects at the line y equals to x. Okay, you must intersect as x, y to be the same value. So say AA, BB, A over 1 over A and 1 over A. So x, y value must be the same. So which one cannot be that point? Okay, obviously part D cannot be the point because it can't intersect as negative A and A. Because if you have negative A and A, on the inverse it will be A and negative A. It won't intersect at that point. Okay, so D cannot be the answer. Is there someone outside? Okay, for question 2. Okay, for question 2. If A and B are real constants, for what relationship? Okay, it asks you about a relationship. You're talking about the relationship between A and B. So for what relationship of A and B will the function f, okay, that's the domain, mapping to R, and fx equals to x squared plus 2bx. So what's this? This is a quadratic. So have an inverse function. Okay, to have an inverse function must means one-to-one function. Okay, so that's the analysis between this question. So we have a quadratic x squared plus 2bx. And I give a domain, but the domain is unknown. So up to a point A, but this A is what I don't know. And I have a variable b here in the equation itself as well. And I say I want this equation to have an inverse function. To have an inverse function means this function first must be a one-to-one function. So now I'm thinking about negative infinity to which point can make a quadratic to become a one-to-one function. Okay, let's think about the general one-to-one function like that. Okay, one-to-one function. So negative infinity to a point. Let's say this turning point is C, comma D. Okay, let's say the turning point is C, comma D. So negative infinity is, okay, all the x values to here. So the graph can be from here to, let's say if we stop at here, then this is one-to-one function. If you go a little bit further, that is still a one-to-one function. If you go more further, that's still a one-to-one function. But I can't keep going from that point. If I go here, that will become a many-to-one function, which means if that needs to be a one-to-one function, I must have negative infinity. The maximum point I can reach is the turning point. Okay, the maximum point I can reach is the turning point. And if, okay, so I can go from negative infinity to the turning point included, or I can go from the turning point to infinity. That's the maximum value I can have. That is the minimum value I can have. That one?
Sorry. You're okay? Yeah, I'll just, is it okay to bring my bag back?
Okay, next lesson I will keep the side one for you.
Yeah.
Wendy, do you want to come to the front? Okay, so the maximum is turning point. Let's say this. Okay, well. Okay, let's say that point is 2, -3. Let's say that point is 2, -3. Then if that needs to be a wants to be a one-to-one function, I can go from -infinity to 2, which is the maximum. I'm not necessary to reach the point 2. I can for -infinity to 1. It's also possible. Okay, it's not necessary to really reach the turning point, but you must stop before the turning point. Or if you start from the turning point to infinity, so you need to start like at 2 to infinity. Or like say I can start from 3 to infinity, which is, like say that's this black part of the graph. That's still a one-to-one function. So if I start after the turning point, so it can be 3 to infinity or any number greater than 2 to infinity. So I want to become a one-to-one function. The maximum set is -infinity to 2 or 2 to infinity. So that's just some explanation about this, and let's see this question. So you can see turning point is the key thing. Okay, turning point is the key thing. Now we have fx equals to x squared plus 2bx. Okay, I want to know where's the turning point. Okay, I want to know where's the turning point. So I can complete the square. So x squared plus 2bx plus half of the middle number squared and subtract half of the middle number squared, and 3 of that can complete the square. That can gives me x plus b squared minus, okay, that's b, so it's b squared. So that is my turning point. Okay, that is my turning point. So turning point will be minus b squared. I don't know like how large is b, I don't know. So I can just draw it not on the axis, but I know negative b squared is the turning point. So we have a graph like that. And I have my domain is -infinity to a. Okay, -infinity to a. So what is the maximum number a can take? What is the maximum number a can take? A can be a lot of numbers. So what is the maximum point where I must stop? I already have the turning point. -b. Okay, a maximally can reach -b. Because that's the turning point. If you go beyond the -b, if a is greater than -b, which your graph will be from here to here and include this will be like that. So it's not a one-to-one function anymore. So the maximum a value can take is -b. So your a value must be smaller or equals to -b. Okay, a needs to be smaller or equals to -b. It's not necessarily always take until the turning point. Like it can before the turning point, or like can be after the turning point to infinity. So there's infinite many domain set you can take, not necessarily only those two. So your a just needs to be smaller or equals to -b. So if it is smaller or equals to -b, you can keep your answer like that, or you can say they plus together to be smaller than 0, because it's talking about the relationship. So that's a relationship. You plus them, you get a number smaller than 0. Or a is smaller than -b. Okay, so that's the relationship. Okay, so let's finish up yesterday's inverse function. And then let's have a look at this 5h. Okay, 5h. A rectangular piece of cardboard has dimension of 18 times 24. 4 squares, each x centimeters times x centimeters, are cut from the corners. An open box is formed by folding up the flaps. Okay, this question is very typical. Like it's always like you have a piece of paper and cut the 4 corners and fold it. Okay, it's like a lot of questions like that. So we can do this. Okay, so we have rectangular. So we have x here. Okay, we cut square here. Like that. Okay, that's the 4 square, each with x. And I'll fold along this green line. Okay, I'll fold along the green line. So therefore, this is my base. Okay, this is my base. The green part is my base. And then the height will be x. Think about it, you cut that and you put it up. So the height is x and the base is the green part. And we have 24 times 18. Okay, that's 24 times 18. So find a function gives the volume of the box in terms of x. Okay, here's 24. Then here will be 24 as well. This part is x. This part is x. Then this length will be 24 minus 2x. Okay. So here is 18. Here is x. Here is x. Then this height will be 18 minus 2x. Okay, 18 minus 2x. So the green bit has length of 24 minus 2x and 18 minus 2x. And the height is x. Okay, the height is x. So volume will equals to length times width times height. You don't need to expand it. Okay, it's not asking you to expand, so keep answer like that. Everyone should understand this step. And the last thing ask you to do is state the domain of the function. Okay, state the domain of the function. So you talk about your x values. So what restrictions do you have on x? Yeah, must be positives. X needs to be greater than 0 for sure, because it's the height, it needs to be have some length greater than 0. Can x be too big? No. So what's the limit? Like, what x can be? 9. How we work on that? Yes, okay. So you have length and width. So you have 3 dimensions on the rectangular. So you have length, width, and height. So all of them needs to be greater than 0. So basically you need 18 minus 2x to be height greater than 0, width greater than 0, and you need your length to be greater than 0. Then height greater than 0 is that, and x smaller than 9 is here, and this is x smaller than 12. So you have 3 set of values. Okay, you have 3 set of values, but I need to find the intersection, because the intersection is gives all of them greater than 0. So we will have 0 here, 9 here, and 12 here. So x greater than 0, let's use this blue. So open circle all the way to the right. And smaller than 9 will be this red one all the way to the left. And 12 will be this green one all the way to the left. It's too high. And you can see you have which part of the graph got 3 colors. You'll be from here to here. But at 0 and 9 are 2 open circles, so not including those 2 values. So it will say x belongs to 0 to 9. Okay, x belongs to 0 to 9. That is the domain. Do you have class tomorrow? Yes. Wait, we have class on Wednesday? No, we are not losing that lesson. Okay, so x belongs to 0 to 9. That's the domain, and that's the equation. Okay, let's have a look at example 2. Let's have a look at example 2. In example 2, okay, so we have a rectangle is inscribed in an isosceles. Change that please. It's not isosceles, it's equilateral. Okay, equilateral triangles with dimension 2x. Okay, it's given not 15, not 2x, 15. So it's an equilateral triangle with dimension 15. And find the area of the rectangle function. Okay, ax. I want to find the area of ax. So what I'm doing is I can draw another rectangle in like this. Okay, I can put different rectangle in, and they have different areas. So the longer the width, the longer the length, the smaller the width, because it will touch the end of this triangle. So you can have another one is, say, here. Okay, it's very thin but tall. Okay, it's very thin but tall. Like that, the black one. So I can have a lot of rectangles in it. I want to find the equation AX. So the area according to this X change. So what is X? The X is half of the length. Okay, half of the length. 2X is the total length and X is half of this. So I want to find the area equation according to the half of the length changing. Okay, so first of all, what we can write is AX equals to what? It's a rectangle. If it's rectangle, then the area must be length times height, right? Length times height. So 2x length times width, like 2x times y. Okay, so the y is here. But this y will change according to the exchange. Okay, y will change according to the exchange. The variable for this function a is only x. You don't have the y here. I cannot put y there. So I need to find the relationship between y and x. Okay, I need to write y in terms of x and substitute back to find the real equation for ax. So let's have a look at this y. So what's special for this y? Okay. First of all, let's see. This is y, right? This is y. How many degrees is that? 60. Okay, 60 degrees. That is y. What's the length here? What's this red part? How long is that? No, don't think about cross in terms of x. In terms of x. Think about that is, it's an equilateral triangle. Okay, the base is 15. Is that 15 is the whole length? Yeah, okay, yeah. 15 over 2, 7.5. Take away 1x. Because that's 2x. Half of that is 1x, okay? So we have this part is 15, the black thing is 15 over 2. And then the green part here is x. Because the whole thing is 2x, then half of that is x. So the red part will be 15 over 2, subtract x. Okay, you have y here, which is the opposite to the 60 degree. And you have the adjacent, which is here. So you need to write a tangent equation. Okay, what's tangent 60 equals to? Tangent 60 will equals to y over 15 on 2 subtract x. Okay, what's tangent 60 degrees? No? You have learned that, right? Year 9, we should learn that. Year 10. Root 3, yeah, it's root 3. Okay, tangent 60 is root 3. Okay, how we find tangent 60 is root 3? I can draw this triangle. It's 1 to root 3. I have this triangle 1 to root 3. And here is a 60 degree. Okay, that's how you remember that. That's a 60 degree. If you don't understand, let's draw equilateral triangle, which each side is 2. And you cut that into half. So that is still 60 degree. That will be 30 degree, and that's 90 degree. Then half of that, this will be 1, because you draw height, and that will be 1. So 2 square minus 1 square is 3. So root 3 is here. Then that is 60 degrees. So tangent 60 will give you root 3 over 1. So tangent 60 will be root 3. Okay, tangent 60 will be root 3. We'll go through circular function second or third term. So root 3 will equals to y over 15 over 2 subtract x. Then y must be root 3 bracket 15 over 2 minus x, like that. Okay, that is the y value. How I can make an equation in between y and x? I have y here. I have some expression in terms of x here. And I have this special angle 60 degrees. And I can work in that way. Okay, I can work in that way. Y equals to that already. So let's come back to here. So ax will be 2x times, okay, what's that? Root 3, 15 over 2 subtract x. So it's 2 root 3x, 15 over 2 minus x, and that will be 15 root 3 x minus 2 root 3 x squared. Okay, expand the bracket. Expand the bracket. And what's the domain? What's the domain? Can x be negative? No. Okay. Can x be very large? It used to be within the triangle, right? So your 2x cannot be smaller than 0 and also cannot be greater than 15. So 2x needs to be in between 0 and 15. So x needs to be in between 0 and 15 on 2. So domain is x belongs to round bracket 15 over 2. Chapter 5. We finished chapter 5. Chapter 4 and chapter 5. Okay, it's everything here. And I haven't really go through this